Hey, good morning or afternoon, depending when you're watching this. Thank you for watching your asynchronous Wednesday notes. Today we are going to be looking at tangent lines, but actually finding the equations of tangent lines. Today, while you're at home watching this, I just want you to watch the basics of the tangent line. We'll look at more of the applications tomorrow in class. But again, to review for you, you know that when you have a function here, say I'm going to call it f of x, we know that that function has a tangent line. And the idea behind what I want us to look at today is we're going to find the actual equation of that tangent line so that it could be graphed on the coordinate plane. So there are some things I wanted to review first. The first is how we can use the derivative. We know the derivative is used to find the slope of the tangent line. So when I say what is the slope of the line tangent to the graph of f at x is equal to a, well, that is the derivative, and then you plug in a into the equation. So if I wanted to find the slope of the line tangent to f at x, again, when you're finding the slope of a tangent, you need to find the derivative first before you plug it in. So the derivative of 3x squared is 6x. The derivative of 2x is 2. 3 is a constant, so it goes to 0. And then we want to find the derivative at 2 because we know the derivative is the slope of the tangent line. So we have 6 times 2 plus 2, which gives me 14. Again, that would be the slope of the tangent at x is equal to 2. So that's the first part of what we're going to do. The second part is we're going to actually write the equation of the tangent line. So to give you an example of that in some notes, I first want to talk about the equation of the tangent line. So back in Algebra 1, you probably learned two different equations for a tangent line. You have the one that looks like y is equal to mx plus b. That is called the point slope form. No, it's not. That is called the slope y-intercept form. And it's because to write the equation, you have to have the slope of the line and you have to have the y-intercept. The one that's easier for us to use in calculus is the one that I tried to say earlier. It's the one that is the point slope form, where you are given the slope and you are given some point that is on the line. And that one looks like y minus y1 is equal to m times x minus x1. So we can translate that into calculus basically. So we still have like our y's and we have our x's. Our slope is going to come from the derivative, of course. So that's going to be whatever f prime of a is. Our x1 and y1, so this is a coordinate that is on the line, is often easiest just to use the point of tangency. So the a value in this case is going to be that x value where we want the graph to be tangent at. And then, of course, to find the y that goes with the graph, we're going to plug that x value into the equation. So looking at this example, I want to find the equation of the line tangent to the graph of f at x is equal to 3. So the first step is to find the equation of a tangent line. You need two things. You need the point and you need the slope. I'm going to go ahead and find the point first because I have the equation. So I want to find the point at 3. So I have 3 times 3 squared plus 2 times 3 minus 3. And then we can easily evaluate that. So I have 3 times the 9 plus 6 minus 3. So the y coordinate is 30. So we have this coordinate on the graph. And then we need the slope. The slope's going to come from the derivative. Again, you have to find the derivative before you can plug in a value. And then I want to find the derivative at 3. So I have 6 times 3 plus 2. That's 18 plus 2, or 20. So to find the equation of the tangent line, I have y minus the y coordinate is equal to the slope times x minus the x coordinate. Now that is the point slope form. You're more than welcome to leave your answer in that way. That is the equation of the line. If you do prefer to write it in point slope intercept form, just make sure you kind of do your math correctly so you can distribute that 20 across. And then you can add the 30. So this would be the equation line as well. Both of those are equivalent. Again, what you found is this is a quadratic. And is a quadratic, it is upwards facing, and we have found the line tangent to that graph at the value of 3. So this graph looks something like this, and we have found that at 3 there is a tangent line the point of tangency we found was at 3, 30, and the equation of that tangent line is this y minus 30 is equal to 20 times x minus 3. To give you another example of the tangent line, let's do one that has trig in it. So if I want to find the tangent line, let's say y is equal to the 4x minus the tangent of x, and I want to find the tangent line at x is equal to pi over 3. So again, if I want to find the tangent line, I need two things. I need a point and a slope. We use the original equation to find the y coordinate of that point. So I have 4 times pi over 3 minus the tangent of pi over 3. So the y coordinate, it looks a little bit ugly, but I have 4 pi over 3. If we need a reminder about the tangent of pi over 3, that's the steeper part on the unit circle. So 1/2 comma root 3 over 2, and tangent is sine over cosine. So the tangent of that would be the square root of 3. So the coordinate is this pi over 3 comma 4 pi over 3 minus the square root of 3. That is the coordinate of the point of intersection. The slope of the tangent line is going to come from the derivative. The derivative of 4x is 4. The derivative of tangent is secant squared. And so we want to find the slope at pi over 3. So I have 4 minus the secant of pi over 3 squared. Again, going back to pi over 3, secant is the reciprocal of cosine. So the secant at pi over 3 is going to be just 2. So I have 4 minus 2 squared, which is going to give you 0. So the equation of the tangent line, I have y minus the y coordinate is equal to the slope times x minus the x coordinate. Now this one is a unique problem. We saw that the slope of the tangent line was 0, and we know that that does mean that it is a horizontal tangent line at this point. So looking at this one, it does kind of simplify. So 0 times all of that's just 0. And I can actually add that y coordinate to the other side. And so both of those are the tangent lines. One's definitely a much more simplified from the other. But basically what we know that on this graph, whatever it may look like, at this point of pi over 3, it does have some sort of horizontal tangent. And what is that horizontal tangent exactly? That is the equation of it, the tangent line that we found. So at this point, you can go ahead and start homework number 3. You definitely don't have to do all of it, but I would recommend starting it. If you're looking at it, I would recommend there's 2 sections. That first page, 114, is going to have a lot of just the basic rules on it. So the power rule, derivatives of sine and cosine, constant multiple rule. The second set is going to have things like the product rule, the quotient rule, and some of our other trig rules thrown in as well. We are going to finish these notes tomorrow and kind of look at some applications of the tangent line. But for now, the rest of your assignment today is to continue working on homeworks numbers 4 through 6. Thanks again for tuning in. Please don't hesitate to reach out if you have any questions about finding tangent lines.